Okay, so now down here at the bottom of the page, they add in the graph for y equals negative x plus 3. Now that equation is explicitly in slope-intercept form, so we can go ahead and jump right into graphing this one here. Go ahead and take a look at the end of the equation for the y-intercept here. The y-intercept is 3. Again, that's the number here, the trailing end. So I'm going to go ahead and put a dot on the y-axis here at 3. Then I'm going to go ahead and grab my slope. So my slope is going to tell me how I move from that point. Now there's no number here in front of x, so of course fractionally slope would be 1 over 1. You know by now if there's no number there, it's the same as a 1, and slope always has to be a fraction, so it's 1 over 1. But there is a negative sign there, so it's not just going to be 1 over 1, it's going to be negative 1 over 1. So slope of negative 1 over 1 means I'm going to rise negative 1, go down 1, and then run 1, go to the right 1. Well, as you can see, as I did that just for the very first jump here, and again, I can keep going down 1 and right 1, down 1 and right 1 over and over, but as I did that very first one, I happened to find the point at which these two graphs cross. These two graphs end up crossing here at 1, 2. And that's exactly what we're looking for because that's the solution. The point at which the two graphs cross each other in solving systems of equations is the solution. The point at which in both equations, in the left plugging in for x and y, I can make the left side equal the right side, again, in both equations. So when I change x into 1 and y into 2 in both equations, that will make the left side equal the right side in both, and thus it's the solution to the system of equations. Alright, so let's go ahead and practice that here. Here's question number 1. Question number 1, they give me the equations y equals x and y equals negative x plus 2. Alright, so if I've got y equals x, that's in slope-intercept form. Again, it's one of those ones we did not recognize as in slope-intercept form, but it's in slope-intercept form. So, I'm going to go ahead and add to the trailing end here a plus 0. So I'm going to go ahead and put a dot on the y-axis at 0. And the slope here would be what's in front of x. Well, since there's no number there, that's 1, or fractionally 1 over 1. So that means I'm going to rise 1 and run 1. So from this point, I'm going to go up 1 and right 1 and put a dot. And again, I can repeat that process over and over again, and I intend to. I'm going to keep going up 1 and right 1 over and over and over again. Alright, and there's the graph of y equals x, or y equals x plus 0. Alright, now we've got y equals negative x plus 2. So, graphing again, according to slope-intercept form, I'm looking at the end here, I see a plus 2. So I'm going to go to y-axis and put a dot at 2. Then I'm going to go ahead and take a look at my slope. Well, again, there's no number here in front of x. That would be like 1, or fractionally 1 over 1. But it is negative, so it's actually going to be like negative 1 over 1. So slope of negative 1 over 1 means I'm going to go down 1 jump, since it's a negative, and then go right 1 jump. So from this point, I'm going to go down 1 jump and right 1 jump. And I'm going to keep going. Down 1 jump, right 1 jump. Down 1 jump, right 1 jump. And I can keep doing that, but as you can see, we have two x's that are on top of each other, and that's going to be my solution. The point at which these overlap is the solution to the system of equations. Well, it's at 1 on the x and 1 on the y, so the solution here is 1, 1. When I change x into 1 and y into 1 in both equations, that will make the left side equal the right side in both equations. Now, number two is a little bit different because both of the equations in number 2 happen to be in standard form. But that's not a big deal. We can graph standard form. We've done that before. As far as graphing in standard form goes, remember that's when we use the intercepts method. That's when we say if x equals 0, find y, and y equals 0, find x, which is something we did late last week. So let's start with the top equation. X plus 2y equals negative 2. Alright, so if I go into this top equation and change x into 0, it says 2y equals negative 2. Well, if it says 2y equals negative 2, that means y would have to equal negative 1. So the graph here of this line goes through the y-axis at negative 1. Now, other way through, we'll let y equal 0. Well, if I let y equal 0, it just says x equals negative 2. So the x-intercept here is negative 2. All right, let's go to the bottom equation. 3x minus 2y equals negative 6. Again, I'm going to do the same thing because this is also in standard form. So if I let x equal 0 here, that means that that left side is going to disappear, and it's going to say negative 2y equals negative 6. Well, if negative 2y equals negative 6, that means y has to equal 3, because negative 2 times 3 is negative 6. So this one goes through the y-axis at 3. Now I'm going to go the other way. I'm going to change y into 0, which is going to make the middle part disappear, and it's going to say 3x equals negative 6. Well, if it says 3x equals negative 6, x has to equal negative 2. That means this graph goes through the x-axis at negative 2. Well, that's luck, because both of these happen to cross over x at negative 2, as you can see when we drew our x's here. So that must be the solution to the system of equations here. They both cross here at negative 2, or written as a point here, negative 2 for the x, 0 for the y, negative 2, comma 0. If I change x into negative 2 and y into 0 in both equations at the same time, that's how I'm going to make the left side equal the right side. Alright, let's go ahead and take a look at the final example here, number 3. Y equals x plus 1 and y equals 2x. Alright, so we're back to graphing here in slope-intercept form. Probably a little bit easier than the standard form, as you can see, comparing numbers 1 and 2. Definitely a lot less work to do. So as far as graphing y equals x plus 1, at the end of the equation here it says plus 1. So that means the y-intercept here is 1. So put a dot on the y-axis at 1. And then what's in front of x here is my slope, which would be 1, because there's no number there, but again, slope has to be a fraction, so it's actually going to be 1 over 1. So slope of 1 over 1 means I'm going to go up 1 and right 1. And again, I'm going to do that repeatedly. Up 1 and right 1. 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 Okay. And I keep going, but I think that's probably going to be enough. Alright, then we've got y equals 2x. That is the slope-intercept form, but you may not realize it. We can go ahead and tag a plus 0 onto the end of that guy, and that will get it in pure slope-intercept form, probably easier to work with for some of you. So since it says plus 0 at the end, that means this graph is going to go through the y-axis at 0. So I'll put my first dot on this one at 0 here. And then I'm going to go look in front of x for my slope. That happens to be 2. Slope of 2 is equivalent to 2 over 1. So that means I'm going to rise 2 and run 1. So from the point I just made, I'm going to go 2 units up and 1 unit over. And as you can see, we happen to have a point of overlap on the very first jump. So that means I have the solution to the system of equations. I'm just drawing my lines in here. And these guys happen to cross each other at 1, 2, 1 on the x and 2 on the y. So my solution here is 1, 2. If I change x into 1 and y into 2, I can make the left side equal the right side in both equations at the same time.